Welcome to True Projects. In this video, we are going to explain about the project which is dark side of the web, that is dark web classification based on TextCNN and topic modeling weight. Before getting into the execution, first let us understand what is the project about. So when you are browsing the internet, you can easily access a number of websites like Google, Wikipedia or social media platforms, etc. But did you know that they are just the surface? So those are just the web surface. There is a whole hidden part of the internet that most people don't even know about it. That is called deep web. And it is much larger than the visible part we see and we use every day. Within the deep web, there are smaller, more secretive space known as dark web. So we do have dark web in the deep web. So this dark web is where things get a little more complicated. While the surface web is full of open, accessible information, the dark web is intentionally hidden from the public view. It is often used for activities that require anonymity. It requires where the people require anonymity both for good and also for bad. For example, people might use it for secure information in oppressive countries to share the sensitive information safely. But unfortunately, it also has a reputation for being a hub for illegal activities like drug trafficking, etc., data theft, and also hacking. And accessing the dark web isn't like your regular internet browsing. You need special browsers like Tor and I2P, which hide your identity and make it hard to track your movements online. These technologies create an environment where it is difficult to trace individuals, making it a prime space for people who want to remain anonymous. That means unknown, whether they are trying to protect their privacy or engage in more nefarious activities. So, this dual nature of the dark web makes it fascinating yet often controversial part of the internet. So when it comes to classifying the content of the dark web, there are some current methods. So we do have some current methods mainly focusing on the word frequency. So it mostly focuses on the word frequency. That is basically counting how many times a certain word appears. While this can give some insight, it misses out on the big picture. It doesn't really look at the context in which those words are used, which is super important for understanding whether the content is actually malicious or not. For example, if the word drugs appears frequently, it might suggest a shady topic, but without knowing the context, whether it is about illegal activity or medical discussion, the classification can be off. To make the things worse, the huge data sets of the dark web, that is on the dark web, are often cluttered with irrelevant and also redundant data, redundant words. So this just adds noise to the analysis and makes it harder for the system to distinguish between useful and useless information. Imagine reading through a bunch of text where half of the words don't even matter to the topic at the hand, and it just makes the whole process of detecting harmful content a lot more complicated. So, current approach of just counting the words without really understanding them leads to a lot of inefficiencies and errors in detecting malicious activities. So, to tackle the challenges of classifying dark web content, this project proposes a new approach that combines topic modeling along with the text CNN. It is a type of convolutional neural network specifically for text. The whole idea is to improve the classification accuracy by focusing on the most relevant words associated with specific types of malicious activities instead of looking at every word in the text. This method filters out unnecessary noise and that will help the system more efficient and accurate. So the system first it employs the label LDA, that is LLDA, which helps to identify important features for each class of activity like illegal drug sales or hacking. LLDA calculates the impact of these words and generates a class specific weight matrix. So it generates class specific weight matrix. This essentially gives the scores to each word based on how relevant it is for that particular activity. Once we have these important keywords, they are used to create pre-trained vectors. So they are used to create pre-trained vectors, which are essentially representations of the words that capture their meaning. These vectors are then fed to the TextCNN model for classification. So by focusing on just the important keywords and reducing the size of the vectors, we are able to streamline the processing. This makes the system faster and more efficient at detecting harmful content without getting bogged down by irrelevant words or unnecessary details. So, moving on to the extension part, in this project, we are extracting features from TextCNN. After that, those features are fed to the CNN 2D algorithm, that is the extension algorithm, which is combined with the LDA text CNN to enhance its accuracy. So, by leveraging the optimized features from the text CNN, CNN 2D can learn more effectively. Additionally, here we have introduced dropout layer in the CNN 2D to randomly drop irrelevant features during training. This prevents the model from overfitting. This makes the model more efficient, robust, and accurate by focusing on the most relevant data while minimizing the impact of unnecessary features. On top of that, we have also built front-end using Flash framework. This was done so users could interact with the model and test its performance directly. Plus, we included user authentication to ensure that access is secure, making sure that only authorized users can interact with the system. This extension not only improved the model's capabilities but also made it more accessible and easier to use for anyone wanted to. So this is about the theoretical concept. Now moving on to the implementation. To implement this project, we have followed the steps of flow of work. So let us understand the steps. First, we started by importing all the necessary libraries and modules that are required for the project. These include libraries for data handling, machine learning, and also text processing. Coming to the next step, we then took a look at the dataset, that is DUTA, that is DUTA, to understand its structure and the kinds of the data we are looking with. This helps us to make decisions on how to pre-process it. The next step is text pre-processing. This step is about cleaning the data. Here we remove unnecessary characters, that is unnecessary punctuation marks, stop words, and non-alphabetic tokens that don't add the value to the sentences. Then we apply stemming and lemmatization to simplify words to their root forms. For example, running becomes the word run. After that, what we did is we clean the data where we convert the text to X and labels to Y into NumPy arrays, which makes it easier to work with in the next steps for processing. Coming to the next step, we extract features from the text by using TF-IDF vectorization. So we use TF-IDF vectorization to convert the text into numerical form so the model can understand it. We also apply dimensionality reduction technique, that is LDA, to reduce the complexity and focus on the most important features for classification purpose. Then we split the data into training and testing sets. This ensures that we can train our model on the part of the data and test it on the test part, keeping the evaluation fair. After that, we define the machine learning models. We define the deep learning models. This is where we decide on the algorithm to use and how it will handle the data. After that, we train the model using training data set. The model learns from the data during the step, adjusts its parameters to make accurate predictions. Then what do we do is after training, we evaluate how well the model is performing using several metrics like accuracy, precision, recall, and FN score. This helps us to understand how effective the model is. Then we compare them using the graphs with all those scores. And coming to the front end part, we built front end using Flash framework to make the model accessible to users. This includes creating a registration and login system with the help of SQLite database to store the user credentials securely. The next part is once the front end is set up, users can input their data by providing information which will be used for prediction purpose. Then before making the predictions, the input data is pre-processed just like the original data set, so model can understand it correctly. After pre-processing, the input data is passed to the trained model to make predictions. Finally, prediction result is displayed on the front end for users to see. This provides the outcome of the classification based on the given input. So this is how we have implemented the project. Coming to the extension part, coming to the algorithms used. These are the algorithms used in this project. So these two are the baseline models which are used for comparing them with the proposed model and the extension. And here is the proposed model, that is LDA topic modeling with the text CNN. Coming to extension, here we have used LDA topics with the hybrid text CNN model. Here we have used CNN 2D as the extension purpose. Moving on to the requirements to implement this project, we need basic requirements which are hardware and software. Coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is all about the project. That is theoretical concept. Now let's execute. To execute, we need to open the code folder that contains source code files. Let us open that. So these are the source code files of the project. Let us understand each of the folder. How will they be used in the project? Let us open this dataset folder. So here, this is the dataset that is used in the project to train the models. So this is the dataset used in this project to train the models so that they will be able to classify the dark web. Here, the first column we have is the vendor column. It is the name of the vendor selling the service. Here we do have some different vendors. First two columns we have is CPay, TV, and Crypti, KOG. Similarly, we have Cybers and etc. Coming to the next column, that is the category. It is a category under which the service falls, such as service hacking, etc. Then we have is the item. It is the specific item or the service being offered. Then we have is the item description. It is a detailed description of the item or a service explaining what it is offered, like how the service works or what are the features are included. Then we have price. It is the cost of the service or item in the Bitcoin, that is BTC, with various services priced differently. Then we have is the origin. Origin, it is the origin of the vendor, which in this case is Torland. We do have multiple origins. Here we have Torland, here we have Australia, etc. Then here we have the destination. This represents the intended recipient or geographical region of the recipient. Then we have as a rating. It is a rating given to the service by users, showing a high rating for all the items listed from 4.93 to 5. So this is all about the columns. Let's close this. Here we do have test data. In this, we have test cases that we will be uploading in the front end to detect that is to classify the dark web. So these are the test cases. Let's close this. Let's get back. Coming to model folder, in this folder, we have the algorithm information and that will be loaded into the project code during runtime of the application. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Then we have is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Then we have is app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. Then here we have is the notebook.ipynb file. That is the dark web classification ipynb file. This is the Jupyter notebook file, which contains the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells. Then here we have signup.db file. This file is a database file which is used to store the user information. Now let's execute, copy the path of the code folder. Now open the Anaconda prompt. So here, Anaconda prompt is open. Now give the command cd, give the space, paste the copied path and click on enter. Here, if you observe, current directory is changed to the code folders path. Now we need to compile app.py file. So give the command python space app.py and now click on enter. So this will compile app.py file and it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which will be the local host and the port unless configured differently. So here we have 127.001 is the local host and 5000 is the port number where application has been hosted by the Flask server. So now copy this local link provided by the Flash server and paste it in any web browser. I prefer Google Chrome, so I will paste it in that. Paste the link, click on enter. And this is the web page of the project, which is displayed in the browser. This is developed using Flash framework. We need to register first and enter all the registration details if you are registering newly. I have already registered, so I'll directly log in. Click on login. Give your username and the password. Click on sign in. We have signed in successfully and we are redirected to prediction page of the. So here you can see a choose file button, right? We need to click on that for uploading the test file, test case file. Click on that. So this is the test data that we will be uploading. Click on that and open. Click on upload. So the given data will be processed at the backend and then train model will be giving us the prediction. So here we have the dark web description. This is the dark web description. So based on the given dark web description, here it has given the classification. It is classified as the category belongs to drugs, opioids, or heroin. Similarly, we do have other test cases also. So for the second test case, this is the second test case that we have given. For that, it has classified the dark web as it belongs to the category of counterfeits or watches. Similarly, we do have classification for the third test case under the all last test cases. So in this way, just by giving the dark web description, the application, that is the train model, will be giving us to the category of which type of dark web it belongs to, which type of category it belongs to the in the dark web. Now let's check with the graphs. Click on graph. So here the first graph we have is the sample outcome graph. Here on x-axis we have all the different types of categories that are being classified in this project, and on y-axis we have the count of that particular class. And here we have the confusion matrix. Here on x-axis we have the predicted class label, and on y-axis we have actual class label, that is the true class label. Here in this diagonally, they are all the actual predictions, and above the diagonal and below the diagonal they are the misclassifications. And this is the extension model's confusion matrix of extension. This is the confusion model's extension graph. Here, this is the accuracy comparison graph. Here on x-axis, we have accuracy score, and on y-axis, we have all the algorithms that are trained for classifying the dark web. So this is the accuracy comparison graph. And here we have precision score comparison graph. Here we have recall score. Here we have FN score. Now click on logout. So in this way, just by giving dark web description, that is the search data description, based on that, the train model will be giving us the category that belongs to that in the dark web. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.